now we're going to look at parabolas, and let's start with the definition. So by definition, a parabola is the set of all points in a plane in which the distance from a fixed point called the focus and a fixed line called the directrix is equal. Okay, well, what does that mean? So the vertex of the parabola is halfway in between this line, which is called the directrix, and it's a dashed line here because it's not actually part of the graph. And then this is the focus. The distance between every point on the parabola and, the distance between the focus and every point on the parabola. So no matter what point I take here, right, I'm talking like this distance or this distance. This, okay, so if that's D1 and this is, okay, this is a separate problem. So let's just look at this D1. This distance is the same as the distance between this point and the directrix. If you draw make that perpendicular to the directrix. So these are equal. Whoops, that's D2. D1 equals D2. So this is just a separate point, different example. So that's D1, and this, again, make that perpendicular, D2. No matter what point you take, no matter how far away you go, this distance is equal to this distance. If you take all of the possible points that have those equal distances, you pick up this parabola. Okay? And so again, like in all of these definitions, I didn't actually derive the formulas for the equations. You can look in your textbook for that if you'd like. It's not actually that hard to derive the equations. Excuse me. So we are going to just look at parabolas with vertex at the origin in this section, and the axis of the parabola, sometimes called the axis of symmetry in college algebra, right, is either going to be vertical or horizontal. And you're used to working mainly in college algebra with parabolas that have a vertical axis because those are functions, right? You get y as a function of x then. And if you recall the formula in standard form, well, we have the general form ax squared plus bx plus c, but also we could rewrite that in standard form, a times x minus h squared plus k. Of course, these aren't centered at the origin. If it's centered at the origin, the first one just becomes ax squared, and then actually this also becomes ax squared. H and k would be 0, 0. So for now, just at the origin. In the next section, we'll look at different vertices. Anyway, my point was, you're used to just looking at either the parabola opens up or down. Now we're going to consider up or down, and also to the right and to the left. So then the axis is horizontal instead of vertical. So in the vertical case, say this is our parabola. So the focus, we use P to describe where our focus is. So this is the point P, 0, 0P. If the parabola opens down, or up, I'm sorry. If it opens down, P is actually negative. P can be positive or negative in these problems. But this one opens up, so I'll leave it as just P. And then the directrix is the line y equals negative P. It's going to be a horizontal line, and it has the opposite sign of P. So if this opens down, this becomes y equals P, and this becomes, the focus is down here instead, 0, negative P. And of course the directrix is up here. All right, so now if it opens right or left, I'll draw it so it opens to the right, but it could open either direction. Okay, so something like this. Then this is the point, P0 is the focus. And then the directrix is vertical instead of horizontal, and this would be x equals negative p. Again, if the focus is over here, then this would be negative p0, and x equals p would be over here. Okay, so when we do this algebraically, of course this isn't a function, so we don't work with this one very much, but we would write this as y equals a times x squared, right? And a tells us how wide the parabola is. Well, now we are going to actually, in the conic section treatment, the standard form is the form where the squared term is isolated, whether it's x squared or y squared. So that if x squared is isolated, it's one of these situations. So x squared equals 4py. So this a here, right, would be 1 over a. The 1 over a is actually the 4p in the conic section treatment. So we're not worried about this treatment right now. We're doing conic section formula. Okay, so when we talk about standard form, we're talking about this form. If the parabola opens side to side, then the form is y squared equals 4px. So the way that I would keep it straight which way the parabola should open, this one's a function because y is just to the first power. You could write y in terms of x easily. Whereas this one, if you wanted to write y in terms of x, you'd have to do plus or minus square root, and that's not a function. So this y squared one opens side to side. So this 4p, once you isolate your squared term, whether it's x squared or y squared, the coefficient here is 4 times p, where p is, one of the coordinates of your focus, depending on which way it's oriented, the parabola is oriented. So of course you could solve for y or x instead, and then that would be 1 over 4p. I usually write it as x squared equals 4py, y squared equals 4px, and then I don't have to worry about 1 over, okay? So isolate the square term, the coefficient on the x or the y, that is the 4p. And then one other thing I want to talk about, actually I think I'll talk about it when we do a graph. Well, I guess I'll do it here. This is P right here. You can find 2 other points on the parabola. So the vertex is 0, 0, of course, you know that point, right? But then, and you know where the focus is. But if you want to get a good graph, you should have a couple more points. So this length here, P, if you double that length, and from the focus go up that length, so this is 2p, and down that length, this is 2p, you'll get 2 more points on the parabola. And I want to see, when I ask you to graph, I want to see those 2 points. So the length between the 2 points here is 4p. This line segment is called the lattice rectum. You don't need to know that or anything, but it does have a name. And so the length of the lattice rectum is 4p. But the main thing is this length here, double it, go up that many units, down that many units, or if it's here, if this is p, go to the right that many units. You can see my graph isn't very good. And to the left that many units, and you'll get 2 points that will help you get the correct width of the parabola. All right, so let's do some examples. This one says, find the focus and the directrix of the parabola y equals negative x squared. That's how we're used to seeing it in the college algebra treatment, and you can think about that with your graph if you want to, kind of verify things both ways. Those are good things to think about. But in the conic section treatment, I like to isolate the x squared term. So x squared is negative y, and then that implies that 4p is negative 1. This coefficient is 4p, so that implies p is negative 1/4. P has a sign, positive or negative. So wherever the vertex is, this one is 0, 0, of course. If P is positive, you go up that many units to find the focus, and if P is negative, you go down that many units to find the focus. Now, up or down because it's the x squared. If this is a y squared, it becomes right for positive, left for negative. So this is not very far from the vertex. P is like right here, just a fourth of a unit away. And if you double a fourth, you get a half. So your other 2 points are here and here. It's really tiny. Maybe I'll blow it up a little bit, actually. And I'll do that by changing the let's change these to 1 and these to -1. Changing the scale, I was going to say. And that's 2, and that's -2. So this is 1, -1, 2, -2, and then ignore those. Okay. All right, that'll be a little better. So -1/4 will be here, and it's like halfway, right? This would be -1/2. And then if I double that, you get, again, a half, so we'll go here and here. And the vertex is 0, 0 on all of these for now. So this is our parabola. And the focus is just 0, -1/4, right? So use this value right here. Quick and easy. All right, in the second one, we want to isolate the y squared. So y squared is -6x. That implies that 4p equals -6. So p equals -6/4, which is -3/2, or -1.5. Now, because this is y squared, this opens right or left. P is negative, which tells us it opens to the left. So here's our vertex, here's our focus. So -1.5, if you double it, you get 3. So go up 3 and down 3 to get 2 more points on the parabola, excuse me. And here is our parabola. Okay, so oh, I forgot to find the directrix. I'll go back to that one. So the focus is -3/2, 0. Directrix would be, so it's the same distance the other direction. You want to draw it, it's right there. X equals +3/2, so the opposite sign of P. So back to this one, directrix is y equals +1/4. So here, can barely even see that on the screen. All right, and make your directrix a dashed line, because again, it's not really part of the graph. Okay, another example here. Oh, actually, I think there's 2 more. Yep, 1 more on the back too. Find the equation of the parabola with vertex 0, 0 and focus 0, 2. Okay, so that's the y coordinate. So if you were thinking about where that is, you know, it's up here. That means this thing opens up. And that's what you need to know to decide whether you need x squared equals 4py or y squared equals 4px. And so since it opens up, it's x squared equals 4py. And of course, this is p. P equals 2. So x squared equals 4 times 2 times y, or x squared equals 8y is the answer. Right, so these are really pretty simple when the parabola has a vertex at the origin. All right, one more question. It says a searchlight has a parabolic reflector that forms a bowl that is 12 inches wide from rim to rim and 8 inches deep. If the filament of the light bulb is located at the focus, how far is it from the vertex of the reflector to the focus? Okay, so when you set this up, the easiest thing to do is just let the vertex be the origin. And of course, you can have it open upwards or to the right. We want it to orient in the positive direction because these dimensions are all positive, of course. If you open it sideways, you got to use y squared equals 4px. If you have it open up, which is what I'm going to do, then x squared equals 4py is the form of your equation. So this parabolic reflector forms a bowl that is 12 inches wide from rim to rim. So from rim to rim, so this is 12 inches. And 8 inches deep. So we need to find P to know how far this filament is. So here's our filament. How far that is from the vertex. So what happens in this, I should maybe mention what happens here. This emits some light, and when it hits the parabola, it actually reflects, right? These angles are equal, and it reflects parallel to the axis, so all the light shines this direction. That's why you like this to have a parabolic shape. Okay, so back to our picture. So we need to find P. How can we find P? Well, we need X and Y. Do we have enough information to find X and Y? And the answer is yes, we do, because we know these dimensions. Think about what this point would be on the rim of this reflector. So this would be, the X coordinate would be 6, and the Y coordinate, you'd go up 8, 6, 8. So just plug in X equals 6, Y equals 8. We get 6 squared equals 4p times 8. 36 equals 32p. And then divide both sides by 32. And p equals 36 over 32, which reduces to, well, 4 goes into there 9 times 9/8, or 1 1/8. And that would be in inches. These were both in inches. So the filament is 1 1/8 inches from the vertex of the bowl. Or, well, I guess I can say bowl, or you can say reflector, whatever. There we go. Okay, so in the next section, things will get a little more difficult because the center switches, but if you understand all these relationships here, you just change where you're counting from. Instead of counting from 0, 0, you just count from that new center or vertex in the case of a parabola, right? That doesn't have a center, it has just a vertex as our frame of reference.